Here we have AP calculus AB problem. Okay, let's go with the information. Let f double prime of x equals to 4x cubed negative 2x, and let f of x be differentiable with critical points at x equals to -1, 0 and 1. Determine which critical values give a relative maximum. Here we have three critical values, -1, 0 and 1. We have to find the one which gives a relative maximum. Okay, here we have the second derivative of the given function, that is f double prime of x. Now, what I have to do is I have to plug in these critical values into the second derivative, that is into f double prime of x. For one particular critical value, if, for example, if f double prime of x becomes positive, that is greater than 0, then we have to say the graph of the given function f of x is concave up at that particular critical value. So what if f double prime of x less than 0, that is negative? Then we have to say at that particular critical value, the graph of the given function f of x is concave down. Okay, so for example, let us consider the graph of the given function is concave up at a particular critical value, say x equals to a. Then we have to consider this point as relative minimum. So that is the graph of the given function as a relative minimum at x equals to a. I mean at the critical value x equals to a. So for example, let's consider the graph of the given function f of x is concave down. So at say this is concave down at a particular critical value, say x equals to b. So this is relative maximum. So the graph of the given function has a relative maximum at the critical value x equals to b. Okay, now what we have to do is we have to plug in these three critical values one by one into the second derivative of the given function, that is f double prime of x. First, let me plug in the first value -1 into the f double prime of x. F double prime of -1 equals to 4 times -1 whole to the third power, -2 times -1. So I'm getting 4 times the evaluation of -1 the whole cube is -1, and negative times negative will become positive 2. So equals to -4, positive 2. Finally, I'm getting -2, which is less than 0. So when I plug in the first critical value -1 for x into the second derivative, it becomes negative. So then what do we have to conclude over here? So the graph of the given function f of x is concave down. Let me write the stuff over here. Now let me plug in the second critical value 0 into f double prime of x. So now let me do it over here. F double prime of 0 equals to 4 times 0 to the third power -2 times 0. So anyways, it will become 0. 0 multiplied by 4 is 0, and this also 0. Everything becomes 0. Since f double prime of 0 becomes 0, so we don't have any information about the concavity, whether the curve or the graph of the given function is concave up or concave down at x equals to 0. So we can ignore this result. So when I plug in the critical value into the second derivative, it has to be either positive or negative so that we can decide. So we have a relative maximum or relative minimum, something like that. Okay, now I'm going to plug in the third critical value 1 into f double prime of x. Let me do it. F double prime of 1 equals to 4 times 1 cube, -2 times 1. So the evaluation of 1 cube is 1, 1 times 4 is 4, and -2 times 1 is 2, which is equal to 2. So here it's positive, greater than 0. So the graph of the given function f of x is concave up at x equals to 1. So now we can consider only the two critical values, -1 and +1, because when I plug in x equals to 0, so the second derivative does not give any information about the concavity, whether the graph is concave up or concave down. So because it becomes 0. Okay, at x equals to -1, the graph is concave down. Let me sketch the graph over here. So here the graph is concave down. So we get the concave down graph at x equals to -1. At x equals to 1, the graph of the given function is concave up. Let me sketch over here. Here x equals to 1. So this is relative maximum and this is relative minimum. So we get relative maximum at the critical value x equals to -1.